We'll build k-means clustering from scratch, the most famous unsupervised machine learning algorithm. A single Java class with point objects, random centroid initialization, assignment, update, and convergence checks. Around 250 lines. We start with a nested point class to hold 2D coordinates. It has a distance to method using Euclidean distance. The toString will help us print centroids nicely later. Points are immutable because x and y are final. The class stores the number of clusters k, the current centroids, and a map from each centroid to its assigned points. The constructor just validates k and sets it. The model must be fit before centroids are available. Fit implements the k-means loop. It first picks k random initial centroids from the data. Then it iterates up to max iterations, assign each point to the nearest centroid, recompute centroids as the mean of their clusters, and check if they've moved. If converged, stop early. We choose k distinct points from the dataset by shuffling a copy and taking the first k. This avoids empty clusters and guarantees the initial centroids are real data points, which improves convergence. This method creates an empty list for each centroid, then for every data point it finds the nearest centroid using Euclidean distance and adds the point to that centroids list. We use a linked hash map to preserve centroid order. Compute new centroids calculates the mean point of each cluster. If a cluster is empty, rare, it keeps the old centroid. Centroids equal checks whether centroids have moved less than a tiny threshold, signaling convergence. Predict finds the nearest centroid for a new point and returns its cluster index. The getters expose the final centroids and cluster assignments after training. We create synthetic 2D data with 3 Gaussian clusters. A k-means clustering with k equals 3 fits the data. The output shows the learned centroids, which should be close to the true centers, and how many points are in each cluster. The centroids match the original cluster centers, and each cluster contains exactly 30 points. The algorithm converged correctly. You've just implemented k-means clustering from scratch. Understanding this core algorithm opens the door to more advanced machine learning techniques and gives you intuition about iterative optimization and centroid-based models.